Using the identity tan squared of theta plus 1 equals secant squared of theta. Okay, so the integral we're going to do is this one. Integral of the square root of 16 plus x squared dx. Okay, so our substitution is going to be let x equal 4 tan of theta. Then dx will be equal to 4 secant squared theta d theta. Secant squared is the derivative of tangent. Alright, now we start replacing things. We get the square root of 16 plus 4 tan theta squared multiplied by 4 secant squared theta d theta. Okay, so if we square that 4 tan theta, we will get 16 plus 16 tan squared theta. And then outside we still have the 4 secant squared. Okay, so just like last time, we can factor the 16 out, take its square root, which gives us a 4, and we'll be left with the square root of 1 plus tan squared theta. But 1 plus tan squared theta is equal to secant squared, so we're going to employ that identity in the next step. So that's going to get us, let's bring this 4 times 4 out, make it 16. And then inside the square root we get secant squared. And then outside we still have that other secant squared. And then if we take the square root of the secant squared, we get secant, and then secant times secant squared will be secant cubed. Now this is an integral that comes up quite often in trig substitution, and I'm definitely not going to go through how you compute this one. It's kind of a long process, but there actually is an easy way to remember it. It's actually equal to the derivative of secant plus the antiderivative of secant all divided by 2. So I'll just put that out here. So the derivative of secant is secant theta tan theta, and the antiderivative of secant, if you have this one memorized, is the natural log of secant theta plus tan theta. And we have our plus c as usual. Although it's a bit cut off, but just imagine there's a plus c there. Okay, now at this stage we need to put the integral, or the answer, back in terms of x. We currently have it in terms of theta. So that means we have to go to our triangle. So let's put a triangle off to the side here. Put theta here. Okay, now let's look back at our original substitution. Original substitution was this. So we're going to build our triangle based on that. X equals 4 tan theta. If you solve that equation for theta, or for tangent, you get tan of theta equals x over 4. And remember, tangent is opposite over adjacent, so that means this is x, this is 4, And therefore this is the square root of 16 plus x squared, using Pythagorean theorem. Alright, so we can replace all of these trig functions with the ratios of these expressions from the triangle. So secant theta, well, secant is 1 over cosine, and cosine is adjacent over hypotenuse. So secant will be hypotenuse over adjacent. So that'll be square root of 16 plus x squared over the adjacent side, which is 4. Tangent is opposite over adjacent. We already know tangent's x over 4 from here. And now we already know these, we just did them. So we're just going to plug them in. So we get plus 8 ln of, hopefully this fits here, 16 plus x squared over 4. And then plus x over 4. And plus c. And then you can simplify this if you want to, but it doesn't really matter. This is essentially the final answer here.